Advanced Algebra, Data and Statistical Reasoning, Standard 2.2. Let's take a look for some definitions. Data is just simply information. That's it. We also have ethics. Ethics are moral principles that guide behavior. Now, when you collect data and work with data, you have to think about ethics. Let's give an example of why that might be important. You want to know if a pesticide causes health problems, which is a noble pursuit, but we have to be careful in how we figure that out. You create an experimental group that eats vegetables treated with this pesticide. So, obvious an ethics violation here. You don't want to put people's health at risk to find out what you need to know. So that's one of many examples of where ethics could be violated. You don't want to hurt people or mistreat them in any way here. We also have privacy, freedom from intrusion. An example of where that may be violated with data collection is to say you have an experiment on exercise and blood pressure rates, which again is a very noble pursuit of knowledge there, but you release blood pressure readings with names of each group. All right, so now if you were to anonymize these readings or get their consent in some fashion, it's one thing, but there are various laws. There's HIPAA laws, which means you can't share health information with someone that really doesn't need to know that information. We have FERPA laws, which are you can't share educational information with people that don't need to know that information, and so forth. So be mindful of the privacy of others when collecting data or working with data. Okay, we also have bias, which is prejudice in favor or against something. Okay, so an example there, you ask a group of mothers who the best dancer in their dance class is, and they choose their own child. Okay, that's an example of bias towards your own, prejudice in favor of your own children. And it may be that you objectively think your child is the best, but you tend to view your own children, for example, with rose-colored glasses. You tend to exaggerate their good characteristics and maybe de-emphasize their bad characteristics. And sometimes it's unconscious. You may not realize you're doing it. So you have to be aware of that potential that maybe the results of the studies say one thing because of a potential bias. All right, we also have confounding variables, which is a variable that can confuse, a variable that can sort of mask the results or influence the results and paint a picture that may be different from what you intend. So, an example of that, let's say we have you want absentee rates and test scores. You're trying to establish, is there a relationship? Students that are absent more, do they perform more poorly on tests? An example of confounding variable will be relative strength of students. Okay, so maybe, for example, you take no caution or no steps towards ensuring that your groups are equal in strength. You just grab a bunch of students, and it just so happens that one of your groups is just naturally stronger than the other. And you may have a kid that's out a lot, but is very intelligent, that does very well, doesn't need to be there as much just because they're so good at it. And they may do well. And you may have a kid with perfect attendance that just struggles with the concepts. So a better way to do that would be to get two groups that are relatively equal in strength. And that way you can magnify the variable absentee rates as an influencer of test scores more so than some other variable. That's just one example. Okay, so part of the standard says when collecting and considering data, critically evaluate ethics, privacy, potential bias, and confounding variables when answering these questions. So think about, are you treating people ethically and not violating their privacy? And is there a potential bias or confounding variable that may be skewing your results? We also have this concept of messy data that the standard talks about, or if you look a little deeper within the standard, it doesn't use the word messy data within the standard, but it does in the commentary. And you have this concept of cleaning data, which is to remove duplicated or irrelevant data. You don't want to count one person twice, or you don't want to count things that really don't matter. Be mindful of incomplete data. So maybe you've got part of what you need, but not all of it. Or can you use the parts you have some way, or do you have to just throw it out? And be mindful of poor formatting or erroneous entries. Okay, things that doesn't look right. So here we have an idea. We've got a weightlifting class trying to compare bench press before and after. Now, Adam looks fine. Barry there, okay, you're missing his bench press after. So maybe you could use this bench press before to help average what the kids were before. But to show growth, Barry, can't be used. You don't know is after. Chris, we have an obvious error. I think the world record in bench press is 700 something pounds. So obviously either Chris is from another planet or something's wrong with that. Okay, and plus you go from 210 to even 540. 540 is an incredible amount to bench press. That would be very, very unusual, especially to go up from 210. So something's wrong with this number. David looks fine, but it looks like maybe this is the same person. You have David and then D. Andrews. So you may consider, well, do I have the same person there? I formatted it different. I had this last name and first initial. So you'd have to clean that up. You may have to toss out Barry, fix this number, eliminate one of those Davids, for example. Big data sets. There's a little bit to say here. Companies can collect data, and it's not just companies, but when you collect data, you can do it in a structured way, like a list of GPS coordinates, for example, which is a nice table in a spreadsheet, or unstructured. Maybe you are collecting information from social media entries, and you have to kind of sort through that. Data can be collected in a variety of ways. Again, going back to the company, you just look at sales and say, how much did that store on average sell on a Thursday? That's one way of doing it, just looking at receipts or customer surveys. Data can be numerical, or it can be what they call qualitative. It could be not numbers at all. So just be advised that when you're working with big data sets, there's different ways of doing it. And there's issues there that you have with it. So this second part of the standard says implement strategies for organizing and preparing big data sets. Okay, so are you going to, how are you going to collect the data? Are you going to sort through surveys? Are you going to sort through some sort of records, spreadsheets? And what are ways to prepare it? So just be aware of things like messy data and different ways of collecting data.